Okay, so we did combine all the translations, transformations, and the next topic is going to be create 3D objects, and then how we can organize the code well so that we have a nice looking 3D object and we can reuse that. So this is done. Um, okay. So let me comment out some of the things to make the triangle look as it was originally and see what we have. So this is without any application of the transformation, right? Okay. So we had this triangle here defined. This is a 3D triangle. And what if I want to have multiple triangles? So before going to 3D objects, what I'm going to do, I'm going to show you how to draw multiple triangles on the same screen. That will be helpful for creating. So we're going to create a class for. So this is technically a 3D object since we have 3 dimensions. Even though the z-axis is made to 0 intentionally, but if I can make a class for this triangle, then it would be easy for us to make a class for 3D objects. So that's what our next plan is to do. What I'm going to do, I'm going to create here a new folder, and I'm going to call this what they're calling it that in the assignment. So geometric shapes, right? So I'm not going to use that long. I can either use shapes or geometry. Let's use geometry. And inside that, I'm going to define the shapes I'm going to create and reuse, right? So let's do that. So in the geometry, I'm going to create a new file and I'm going to call this, let's say, shape maybe, or let me be more specific. Eventually, I'll create a cube, but for now, I'm going to create a triangle.js, right? So let me do that. So this is a blank file with nothing in it, right? And we have the triangle right now defined here. Okay. I'm going to transfer our triangle to a class so that I can have multiple triangle objects. And eventually following the same concepts, they're going to create cubes. So let me create this class and I am going to call this triangle. So these triangles, this is actually OpenGL has something called triangles, a primitive. We don't want to conflict with that, so I'm going to make it triangle and all lower cases. So this is going to be my class. So the first thing in the class is going to be the constructor. And this constructor is going to define our vertices. And I can just copy the thing instead of defining a new triangle. So this is my vertices, right? So I cannot use this let triangle variable anymore. I'm going to use the proper format, which is going to be this. And then I can use a variable for defining the vertices. So we can use just V, which would be less self-explanatory. So we can use vertices. That would be more self-explanatory. Okay, so this is our simple class, right? And I only have the vertices here, nothing else. So let me use this instead of hard coding this thing here. So I'm going to remove this, or let me use the variable. Instead of using this, let's use a new object. So I can use new. So this is going to be conflict now because this is also triangle. I'm going to create a new triangle class. And then let's call this triangle 1. That would be better. And if I try to run this now, there will be a bunch of errors because this triangle is not defined. And this triangle is not defined now, right? And then we need to just make sure that that error doesn't happen. Okay, first thing is to make sure that our triangle is working here. Even though this is going to throw an error, I'm just going to take the risk and I'm going to print our triangle 1. Even though if I don't see anything on the screen. So this was obvious because triangle is not defined. Line 65 and some other places. So let's go to line 65. Okay, so this is a different problem, right? So triangle is not defined because we don't have any reference to the triangle class here. I know the class is defined somewhere in the same directory, but did I add that? For example, I added things inside the lib, but I never added this triangle. So I need to do one more extra step. I am going to load the geometry. Let's say the exact word we have here. Or just make it simple. Or geometry, because this can be 3D or 2D. And I'm going to use this same tag to import the triangle. So it is inside geometry. And then triangle. Okay, so that should solve the issue at hand. Okay, so still not defined. Okay, we have our triangle. Oh, that's a big no. So there was this typo, the capitalization. Yeah, now it's working, right? So even there is no shape because the triangle variable was not defined, but at least we know the objects are now created. So we can create this object. I'm going to use this thing, this object, for rest of the drawing. And what I need to replace, the first thing is replace this. But this is expecting a list of vertices. That's why I'm just going to use the vertices here. And then also same thing goes for this one. And I hope this is going to, yeah. So now I have the shape back. But now this is in a more organized way, and I have this triangle, which is in fact now an object, 2D object, 2D shape. So I can have multiple triangles now, right? And how can I do that? So let's say we have another triangle here. I can define another triangle. Where exactly did I define that? Here. So I can have another triangle here. And let's say this triangle is triangle 2. And I can decide to draw both of the triangles, right? Even though they will be overlapped. And I will need to define more code here, but still that is possible. At least now we have two objects, two triangles. That is possible. So eventually this concept will be useful because your blocky animal will have small parts that may be created using the same cube. So how to have multiple objects? Before doing that, let's try to create a cube maybe. And try to see if we can draw the cube. So I'm going to go back to our geometry, and I'm going to copy the same thing here. And I'm going to rename that to cube. So if I open this one, this is actually having the same triangle, the points, nothing new, right? So I'm going to make this a cube, and I need all the vertices that I can use for drawing a cube. So that is something you can calculate using like a simple drawing on your screen or on a piece of paper. The shortest way would be using the code from the book. So if I go to the book, again, WebGL Matsudalia, and then in the examples, you see they have many 3D objects. Like they have a cube here, hello cube, right? I believe they have more cubes somewhere. So triangles, animation. I believe this is the first one. So this is a colored cube. This is a hello cube. I'm going to just get their position for the cube, which is this one. Well, so this is defined differently. They're using a different way of drawing object. So instead of draw the arrays, they're using indices as well. Actually, I have the cube already calculated here. So what I'm going to do, I'm going to copy this from my previous code that I am also going to upload at some point. So these are the points required for a cube, right? So now we have color and we have the location, but I don't need the color, so I can. Oh, this is a lot of work, but still I need to delete all these things. We'll use that later eventually, but I don't want to show the colors today. So that's why this change of plan is needed. Okay, so hopefully this will help us to draw a cube pretty quickly. So let me, instead of using a triangle, let me see if I can draw a cube on the screen. So I have this triangle, and now I have this cube 1. That is another object from the cube class. And which I don't have added here. So I'm going to add that here. And then I want to use this to draw the cube, right? So I'm going to replace this cube with this. I'm going to replace the triangle with the cube. Cube 1. And then I'm going to replace the triangle with this cube. And I want to see if at least that shows up on the screen. So it's taking the whole screen, right? That makes sense because the way we define the cube, we are using the whole unit cube, right? That's why our screen starts from -1 to +1, and the cube is drawn for taking the whole screen. Let's see now our transformation functions are going to be handy. So let's do a quick scaling and make the cube half for all of the axes, right? So let's do this and see if this works. And then let's apply the scaling and see if that makes the cube smaller. So now the cube looks smaller, right? Can I do a quick rotation of the cube? Let's see. Let's make the rotation now along x-axis because that will make more sense, right? Oh, I never applied the rotation, so I need to do this. So now you can see actually the top and the side of the cube. This looks different, but what if we apply another rotation? And maybe, so this rotation was done alongside x. Now what if we rotate alongside, so x, y? That would look more like, we'll see a corner of the cube that would look more like a hexagon. That is what I'm expecting. So let's create different rotations. So this is our rotate m. Let's call this rotation mx because this is rotation alongside x-axis. And what I'm going to do, I'm going to define it another rotation. Actually, I can, if it's the same angle, I can rotate it here without any changes. But that is not I'm going to do in the future because I want to have separate rotation matrices, and then I can apply separate angles. But for the same angle, let's do that first and see the result. Somewhere I didn't define the mx. Yeah, here. So probably this looks a better version of the cube, right? So this is more like a rotated cube. And even though the sides of the cube is not clearly visible, we sort of see how a rotated cube would look like. I want to do it in a better way so that we can have separate rotation angles for separate axes. So I'm going to copy the thing from here, and then I'm going to have another rotation matrix called rotation my, and this will only apply for x-axis. This will only apply for y-axis. And let's rotate maybe 60 degrees around y. Okay, now I have two rotation matrices, but they are not applied to the model matrix. So I just need to add one more line here. And I hope I changed everything. And let's take a quick look and see how we can have a different version of the cube. So I'm drawing triangles for the cube. Let me actually see the wireframe or the outline of the cube. I can do that using line loop. Let's do that. Let me see what is the, I don't want to make any mistake. And I want to make sure I'm doing the right draw element. So this is the line loop. This is the modes of the drawing. Right? So we can do these things. I use these triangles. You can use line loop or line strips or lines. Just lines is not going to work here. I want to draw a bunch of connected lines. So this is sort of a rough wireframe of the cube with one side missing. But still, it looks more like a cube. So I want to go back to the triangle, and then this is it. Okay, so at this point, let's try to have multiple objects on the screen and how we can do that. Okay, so the easiest way of doing that would be having multiple buffer. So we have this buffer here that is drawing the cube. So we can have the same thing again for another object, right? That is not going to be a very good way of doing that. That's why we have this instruction here that is saying you to have a function like a draw cube function, right? And or a draw circle function that will just draw some shape. So since now we have two different shapes, we have a triangle and we have a cube, we can have a draw cube function. So let me remove this triangle from here. And I should have these colors removed here from here, right? Because every time I am drawing, if I clear the whole thing, no new shape will be shown. But for your case, you need to do some more stuff like depth test and clear color buffer. These are required for 3D objects. I hope that I can show more that in the next lab. But for today, let me rename this to draw cube. And we're using this draw cube function. And I'm passing the GL here because the GL is local. I'm making this gel global so that I don't have to pass it every time I want to draw something. So some small changes, and then just to make sure that everything is working. So triangle 1 is not defined. Triangle 1 is where, triangle 1 is still somewhere. That is line 68. Let's see what we have in line 68. Line 68. Oh, that print statement, which is not required at all anymore. So we have a draw cube function, right? With all the transformations done here. Okay. So actually, we want to make some changes here. Let's say for the cube, I want to have other options. Or let's go back to the triangle because this cube is too long to add anything else. The triangle is shorter. I can go back to the triangle. Let's say triangle 1. Let's call this draw. Oh, let's go back to draw. And I'm going to use this triangle again just to clean my code. I should have a rotated triangle. That looks sort of weird. But that's fine. We are going to remove all this anyway. So in the triangle, I want to have more functions, right? I have this vertices, right? Then I want to have the model matrix. Instead of having the model matrix here, I want to have all these things already defined in the triangle. So what I'm going to do, I'm going to define a model matrix here. So this model matrix, and then I can do a new matrix. Not matrix, matrix 4, right? And then I'm going to define its own private transformation matrices, right? So I'm going to create this. Let's call this translation matrix. And we need 2 more. This is a rotation matrix. This is a scale matrix. So now our triangle object has some more additional properties. That is going to do the rotations, translation, and everything. And I'm going to create a few functions to set these matrices up. So I'm going to call translate. And inside the translate, I'm going to create X, Y, Z. Right. And inside that, I'm going to just set the translation. So this is my translation matrix, right? And for this one, I'm going to set the translate. Similar, I'm going to actually replacing everything I did here. So I had this set translate. I don't want this here anymore. That's why I'm moving everything here. And that is going to be X, Y, and Z. Similarly, I want to have my own function for rotate and scale. Rotate and scale. And I want to have the rotation matrix here and scale matrix here. And also need to set the rotation and the scaling. Okay, so for set rotate, let's go with rotation alongside one axis. So I'm going to call this angle, and I'm defining this. So eventually I'll need a rotation X, Y, and Z, 3 different metrics, right? So let's actually call this rotate X. I am not going to create the other copies for now. So I have too many. Actually, I can do this as well. So now I have a rotation X. Oh, I don't need the whole thing. I just need the angle. Not the scale. So the scale is okay. That is just a set scale. And this is 1, this is 1, this is 0, this is Z-axis, this is Y, this should be Y, this should be Z. Okay, so I hope the triangle is still going to work, and I have a model matrix, but I don't want to do all of these things anymore here. So I'm removing all the transformations. And also the model matrix. Let's keep the model matrix here for now, because I just want to check the code I wrote it is working or not. So this is again back to the original form. But if I want to use my functions from the class, how would I do that? So instead of using this model matrix, can I use the model matrix from the triangle 1? That's the thing we am going to do. So I'm going to use triangle 1, and then I'm going to use this model matrix, and I mean removing everything and see if it works. So it works, right? And let's see, instead of doing any transformation here, can I use a transformation from my triangle 1? So if I do a triangle 1 transformation, I would need to do this. So let's start with the simplest simpler transformation. That is the translation. So I have this translate function. That is this. And if I set this, I want to translate by, let's say, 0.5. And rest of them are 0. So this will have no effect so far, right? Because I did not apply any multiplication to the model matrix. So if I run this, you'll see nothing happens. But I do have this model matrix that I am applying here. So what I can do here, I can do this dot multiply, and then I can apply my translation matrix from here, right? So this works, right? So all the transformations I have now defined in my class is going to work for the triangle. Okay, so I am just going to simplify that, and I don't want to have all these functions for cubes as well, because the cube itself is a lot of things now. So what I'm going to do, I'm going to create a common class, and I'm going to copy this. I'm going to call this geometry. This is I'm going to use for all the geometry in the future, right? So this is my triangle. This is my geometry. I don't want to define any vertices in the geometry, right? So I will have a constructor, and these vertices is going to be blank, right? But in the triangle, I'm going to reuse the geometry. So I'm going to call, say, extend geometry. And then I'm going to only have these vertices. But before that, I'm going to call the superclass. So this is my constructor. I need to keep the constructor. I don't need these things anymore. So now, if I run the code, hopefully, okay, geometry is not defined. Makes sense because geometry was not defined here. So triangle was already declared. Did I change the name? I don't think so. Okay, so this should be geometry. Now the triangle is not defined, geometry is not defined. So triangle1.js, we have this problem. We have the constructor, we have the super. I have the geometry defined here now. The geometry.js is here. Okay, maybe something else is missing. Triangle is not defined, line 66. So triangle is not defined. Right, so I must miss something. Also, we're out of time. So if you want to leave, that is fine. I'll complete, fix this error and upload the video so anyone can watch that. Let me check why I have this. So let me double check from HTML. I have the triangle.js, I have the cube.js, I have the geometry.js. Then should not be a problem. So I'll just remove this. Okay, here we go. So yeah, that was the thing. When we are using this geometry as a superclass for these two other classes, the only problem was we need to import the geometry first, then we need to create these subclasses because they are extending on the geometry. They need to know that they have the geometry. So this was a pretty simple problem. So we are done with this 3D object creation. And before finishing, let me also do the same thing for the cube. So now I can do the extension for the cube as well. In the constructor, I just need to call the superclass. And then if I replace my triangle with a cube, and try to draw that, with including the translation, that should work. Unexpected token. I must have missed something. Super. That's weird as well. Oh, not here. It should be inside the constructor. And now triangle 1 is not defined. That is an easy fix. So what do we have? Triangle 1, line 108. So this should be cube 1. So we have this very large cube. There is no scaling. So we can just apply the scaling, and that should fix the problem with the size of the cube. Anyway, so at this point, we can easily call this draw cube. And then let's do the scaling and make sure that we are doing the right thing. So scale, and that would be same for all of this. And I believe that is scale. So now we have this scaling in the translation. And I think we are good with the drawing for the cube. So I'm going to stop here. We are already out of the time and we're hitting 2 hours mark. So next day, we're going to do the rest of the concept. That will be some color and some animation of the cube.